From the dawn of humanity, we have gazed up at the stars and wondered about our place in the universe. The cosmos, with its infinite expanse and celestial wonders, has always beckoned us to explore its mysteries. We have sent probes to distant planets, landed rovers on Mars, and even walked on the Moon. Yet there remains one celestial body in our solar system that has proven to be a formidable challenge for human exploration: Mercury. Mercury, the smallest and innermost planet in our solar system, is a world of extremes. This tiny planet, slightly larger than Earth's moon, orbits the Sun at an average distance of about 36 million miles, or 58 million kilometers. Its proximity to the Sun means it experiences some of the most dramatic temperature variations in the solar system. During the day, Mercury's surface is bombarded by intense solar radiation, causing temperatures to soar to a blistering 800 degrees Fahrenheit or 430 degrees Celsius. This is hot enough to melt lead, making Mercury's daytime environment incredibly hostile. These extreme temperatures are hot enough to melt lead. The lack of a significant atmosphere means there's nothing to shield the surface from the Sun's relentless heat. As a result, the landscape is scorched and barren, with vast plains and craters that tell the story of a tumultuous past. At night, however, the lack of a substantial atmosphere to trap heat causes the temperature to plummet to minus 290 degrees Fahrenheit, or minus 180 degrees Celsius. This dramatic drop creates a stark contrast to the daytime heat, making Mercury one of the most thermally extreme places in the solar system. This extreme temperature swing makes Mercury a place of stark contrasts, where scorching heat and frigid cold exist in close proximity. The planet's surface is a testament to these extremes, with regions that have been baked by the sun and others that have been frozen in the darkness of night. Despite its harsh conditions, Mercury continues to intrigue scientists and astronomers who study its unique characteristics to learn more about the formation and evolution of our solar system. Missions like NASA's MESSENGER and the upcoming Bepi Colombo have provided invaluable data revealing details about Mercury's composition, magnetic field, and geological history. These missions help us understand not only Mercury but also the broader processes that shape planetary bodies. One of the most fascinating discoveries is Mercury's large iron core, which makes up about 85% of the planet's radius. This core generates a magnetic field, albeit much weaker than Earth's, offering clues about the planet's interior and its geological activity. The surface of Mercury is also marked by numerous craters, some of which are billions of years old. These craters provide a window into the early solar system, preserving a record of ancient impacts and the planet's dynamic history. As we continue to explore Mercury, we uncover more about its extreme environment and its place in the solar system. Each discovery brings us closer to understanding the complexities of our cosmic neighborhood and the forces that have shaped it over billions of years. Mercury's close proximity to the Sun is a major obstacle to human exploration. The intense solar radiation bombarding the planet would be lethal to humans without extensive shielding. Even with advanced spacesuits, the amount of time astronauts could spend on the surface would be severely limited. The Sun also exerts a powerful gravitational pull on Mercury, resulting in a highly elliptical orbit. This means that Mercury's speed and distance from the Sun vary greatly throughout its orbit, further complicating any potential missions to the planet. Unlike Earth, Mercury has virtually no atmosphere to speak of. This means that the planet is exposed to the harsh environment of space without any protective layer. The lack of atmosphere results in extreme temperature fluctuations, with daytime temperatures soaring to 800 degrees Fahrenheit and nighttime temperatures plummeting to minus 290 degrees Fahrenheit. These conditions make it incredibly challenging for any form of life to exist on Mercury. This lack of an atmosphere has several implications for human exploration. Without an atmosphere, there is no air pressure to support human life, and the absence of a protective layer means that harmful solar radiation bombards the surface. This radiation can cause severe health issues for astronauts, including increased risks of cancer and other radiation-induced illnesses. Additionally, the lack of atmospheric drag means that spacecraft must rely entirely on their propulsion systems for maneuvering and landing, which complicates mission planning and execution. First, it means that there is no air to breathe on Mercury. Astronauts would need to carry their own oxygen supply, which would add to the weight and complexity of any mission. The logistics of transporting and storing sufficient oxygen for extended missions would be a significant challenge. Moreover, the equipment required to provide a breathable atmosphere within habitats and spacecraft would need to be highly reliable and efficient to ensure the safety and well-being of the crew. Astronauts would need to carry their own oxygen supply, which would add to the weight and complexity of any mission. The logistics of transporting and storing sufficient oxygen for extended missions would be a significant challenge. Moreover, the equipment required to provide a breathable atmosphere within habitats and spacecraft would need to be highly reliable and efficient to ensure the safety and well-being of the crew. The absence of an atmosphere also means that there is no weather on Mercury, so astronauts would not have to contend with storms or wind, but they would need to be prepared for the extreme temperatures and radiation. Second, the absence of an atmosphere means that Mercury is constantly bombarded by micrometeoroids and solar wind. These high-speed particles can be extremely damaging to spacecraft and would pose a serious threat to the health and safety of astronauts. The surface of Mercury is covered in craters from these impacts, and any mission to the planet would need to include robust shielding to protect both equipment and personnel. The solar wind also strips away any volatile compounds, such as water, that might be present on the surface, making it even more inhospitable. These high-speed particles can be extremely damaging to spacecraft and would pose a serious threat to the health and safety of astronauts. The surface of Mercury is covered in craters from these impacts, and any mission to the planet would need to include robust shielding to protect both equipment and personnel. The solar wind also strips away any volatile compounds, such as water, that might be present on the surface, making it even more inhospitable. Despite these challenges, the exploration of Mercury offers valuable scientific opportunities, such as studying the planet's geology and understanding the formation and evolution of our solar system. Adding to Mercury's inhospitable environment is the lack of a global magnetic field. Earth's magnetic field acts as a shield, deflecting harmful solar wind and cosmic rays away from our planet. Without this protection, astronauts on Mercury would be exposed to dangerous levels of radiation. This radiation exposure could lead to a range of health problems, including radiation sickness, cancer, and damage to the central nervous system. The lack of a magnetic field is a major obstacle to long-term human presence on Mercury. Section 6. The Technological Gauntlet. The extreme conditions on Mercury present significant technological challenges for human exploration. Developing spacecraft and spacesuits that can withstand the intense heat, radiation, and micrometeoroid bombardment would require groundbreaking advancements in materials science and engineering. The lack of an atmosphere also makes landing and taking off from Mercury extremely difficult. Without air resistance to slow down, spacecraft would need to rely entirely on their engines for maneuvering, requiring vast amounts of fuel. Section 7. The Vision of Future Explorers. Despite these challenges, the human spirit of exploration remains undeterred. Scientists and engineers are constantly pushing the boundaries of technology, developing new materials, propulsion systems, and life support systems that could one day make a human mission to Mercury possible. Section 8. The Power of Human Ingenuity. Throughout history, humans have overcome seemingly insurmountable obstacles in their quest to explore the unknown. From the depths of the ocean to the heights of Mount Everest, we have consistently pushed the limits of human endurance and ingenuity. The challenges of exploring Mercury may seem daunting, but they are not insurmountable. With continued investment in research and development, we can develop the technologies needed to unlock the secrets of this enigmatic planet. Section 9. Unlocking the Secrets of the Universe. The universe is vast and full of mysteries waiting to be uncovered, from the twinkling stars in the night sky to the distant galaxies far beyond our reach. Each celestial body holds secrets that can help us understand the very fabric of existence. Exploring Mercury is not just about conquering a hostile world. It's about expanding our understanding of the universe and our place within it. Mercury, the closest planet to the Sun, presents a unique set of challenges and opportunities for scientists and explorers alike. Its extreme temperatures and lack of atmosphere make it a harsh environment, but these very conditions also make it a fascinating subject of study. By studying Mercury's unique geology, composition and history, we can gain insights into the formation and evolution of our solar system. The planet's surface is covered with craters, ridges and plains, each telling a story of cosmic impacts and volcanic activity. Scientists analyze data from spacecraft missions to piece together the history of this enigmatic world, revealing clues about the early days of our solar system. The pursuit of knowledge and the drive to explore are fundamental to the human spirit. From the early astronomers who first charted the stars to the modern-day scientists and engineers who design and build spacecraft, our quest to understand the universe has always been driven by curiosity and a desire to push the boundaries of what is possible. Each mission to Mercury and beyond is a testament to human ingenuity and determination. As we continue to push the boundaries of what's possible, we can look forward to a future where the mysteries of Mercury and other celestial bodies are revealed, enriching our understanding of the cosmos and inspiring generations to come. The data collected from these missions not only helps us understand Mercury, but also provides valuable information that can be applied to other planets and celestial bodies. This ongoing exploration fuels our imagination and drives technological advancements that benefit all of humanity. The journey to unlock the secrets of the universe is a never-ending adventure, one that promises to bring new discoveries and insights with each passing year.